So today will be our first session on this Kubernetes. Okay, so today it will be like introduction to Kubernetes, and we'll discuss what are the components of Kubernetes master and Kubernetes worker nodes. Okay, so now we discuss about Kubernetes. Okay, so what is Kubernetes? So Kubernetes is an open source tool for orchestration. Okay, so we already discussed only directly no one is going to use only Docker. Okay, so Docker, if you are using only Docker on a standalone machines, then who is going to manage it? If where is going to get the high availability, and how you are going to do auto scaling of containers? If how you are going to do auto scaling, scale in and scale out, and scale high availability for your virtual machines. Okay, and how you are going to configure load balancing. So like these kind of a lot of things we cannot achieve only if you're using a Docker inside and virtual machines. So you need to have an orchestration tool which will do all these things and many more things you can achieve with the orchestration tools. Okay, so in the market we have orchestration tools like Kubernetes and Docker Swarm, Mesos, and Cloud Foundry. So these are the tools we use for orchestration. Okay. So now, why Kubernetes is more popular? Because see, in the Docker Swarm, we don't have those many options compared to Kubernetes. Okay. Slowly we'll come to know what are those options. So lot of components we can create, lot of objects are available inside the Kubernetes compared to Docker Swarm. So that's why we are going to use Kubernetes. So Kubernetes basically it's a product of Google. Okay, so it's a product of Google, and they were using this Kubernetes from very long ago for their internal applications backend for containerization. They are using orchestration tool as a Kubernetes. I think I'm not sure exact year, but they gave it to the CNCF. Okay, so as an open source, they gave hand over this tool to this CNCF as an open source tool. So now everyone can able to use this tool. And Kubernetes is having very big community also. So if we have any issues, we can approach that community for taking any help. And Kubernetes is also having a Slack channel like in real time. Like for example, whenever you face any kind of issue while you are implementing, so you just register to the Slack channel with your email ID, and you can post your questions personally also. Like if you have anything you want to configure, so that you can get the help from that community also. Okay, so here the Kubernetes. First of all, we'll discuss about the components of the Kubernetes, the architecture of the Kubernetes. Basically, that Kubernetes architecture bit complex, and the types of installation methods is also a bit complex. But once we start working on it, then it will be easy to understand. Okay, so how the architecture will be looks like in the Kubernetes. So those who are from the Linux background or infrastructure background, like Windows administrator. So Windows administrators or Linux administrators might be aware of over it as cluster, or Windows administrators might know Microsoft cluster. So it's like similar to that. Okay, so those are from the infrastructure background. For them it will be very easy to understand this architecture or maybe the concepts of the Kubernetes cluster. Okay, so it will be like master and worker node concepts will be there. And so in the master we have a components called a API server, kube controller, scheduler, and HCD. Okay, so these are the four components will be available inside the master. So it will be uh, Assume this will be like API server, and this will be like a scheduler, and kube controller, and etcd. Okay, so these are the components of master server, and here we have a components called kubelet and kube proxy. These are the two components. Apart from this, we have another components called um, pods and containers. Okay, so these are the components inside the master and worker nodes. So first we'll talk about what is this API server. So API server is like a gatekeeper. Okay, so what is API? So API will receive calls. Okay, so it's like a kind of a gatekeeper for our entire cluster. So here, whatever the things you want to do, whether you want to create any component object, or you want to delete it, or you want to view it, so we have a command line tool called kubelet. Okay, so with this with the help of this kubelet tool, we are going to get the information. We can create it, we can delete it, any components, we can view it. All these requests will go API call to the API server. So API server validates and configure the API objects, such as like what are the pods we are going to create. We want to create services, replication controllers, deployments, jobs, volumes, secrets, config maps, anything whatever we want to create or delete or view. So what are the commands we execute? It will send the API request to this API server, and from here API server will take care of creating or viewing that particular objects. Okay, so it's like it will perform any operations that we issue from the command line. Okay, so that is an API server. And what is scheduler will do? So before scheduler, if we talk about kube controller, so again in kube controller we have uh, four controllers. One is replication controller, one is node controller, and third one is endpoint controller, and fourth one is service account token controller, I think so. Okay, so again in kube controller, four separate controllers will be there. One is replication controller. So what does it mean, replication controller? Replication control means, for example, I'm creating an application. So if I mention replicas equal to 2, then it's responsibility of replication controller to maintain that 2 replicas compulsory for that application. So if any problem with any of the uh, container, then it's responsibility for replication controller to make sure that always it should be available with 2 replicas. So that's the purpose of replication controller. In the Kubernetes document also we can go kubernetes.io, and documentation, concepts. Every time these guys will change the pages completely. Okay, this is how something looks like: API server, HCD, kube scheduler, and kube controller. And so we are talking about a control manager, and this is a replication controller responsible for maintaining the correct number of pods for every replication controller object in the system. So as I said, if you are mentioning 2 or 3, then the replication controller responsibility for that one, and node controller responsible for noticing and responding when nodes goes down. So whenever any nodes, worker nodes are having any problem, so it's responsibility by the node controller to manage it. Okay, and endpoints controller populates the endpoints objects, that is joint services and pods. See, here we have a concept of pods. Very soon we'll discuss what is pod. It's like assuming it's a container to run an application. So when the container or pod gets created, to access it from the external world, we will create a service like load balancer. So when we create a load balancer, how come it knows that it should connect to the specific application? So it will create an endpoint between the uh, load balancer and pod. So it will create an endpoint. So with the help of this endpoint, this load balancer will connect to this specific set of pods. If it is a replicas or multiple replicas, to access this, it will create an endpoint. So that is going to be taken care by the endpoint. When we talk about this service, load balancer or node pod, at that time we can discuss in detail about what is that endpoint, all these things. Okay, we can see practically also. And scheduler, what scheduler will do? So scheduler component that watches for newly created pods with no assigned node and selects a node for them to run on. So whenever, let's say with the kubelet, I send a command line to create a pod. So it will go to the API and API will tell to the scheduler that to create a pod. So scheduler will decide on which node it should create that pod. Okay, wherever the sufficient resources are available. So it will go and deploy that particular pod on specific worker node. So that's the responsibility of the scheduler. Okay, and HCD consistent and highly available key value store used as a Kubernetes backing store all the cluster data. So HCD contains all the cluster information. Basically, if you want to take the backup of your cluster, you can take the backup of this cluster. If your Kubernetes cluster uses HCD as its backing store, make sure you have a backup plan for those data. So the cluster complete content will be inside this HCD. So if you want to take the backup for maintaining high availability, if it is crashed again, you can restore it with uh, some methods. Okay. So this is the API server is a component of the Kubernetes control plane that exposes the Kubernetes API. The API server is the front end for the Kubernetes control plane. So the main implementation of Kubernetes API service, Kube API server, is designed to scale horizontally. That is, it scales by deploying more instances. Okay. So these are the main components of the worker nodes. Okay, and coming to these main components of master server, and this is the components of worker nodes, and this is master and these are worker nodes. So what is kubelet? An agent that runs on each node in the cluster. It makes sure that containers are running in a pod. So its responsibility is, kubelet responsibility is, for example, here one container or resume pod is running. So kubelet responsibility is to make sure that whatever the pods are running inside these worker nodes are running fine or not. If anything is problem with this pod, then it's responsibility for kubelet to restart that pod. Okay, even though after restarting it will, it's not coming up, it will keep on restart. But if the problem is with the worker node, maybe with the hardware or maybe with this particular worker node, then kubelet will intimate to the master. Okay, so then what master server will do, it will intimate to the, or it will intimate, master in the sense it will intimate to the replication controller. Okay, in the kube controller it will intimate the replication controller, because replication controller responsibility to maintain the value whatever you define, whether it's 1 or 2. If you define only 1, means one container is not running properly, then replication control responsibility to make sure that one always should be available. So this kubelet will intimate to replication controller, and replication controller again intimate to the scheduler. So what scheduler will do? Scheduler will deploy that pod in another working node. So it will be created over here or here. Okay. So that because here there is a problem with the worker node. So that's why kubelet is intimating to the replication controller, and replication controller will intimate scheduler. So scheduler will go and create that pod in a different worker node. Okay. And this will be go into the crash loop back off or some other state. Okay. So that's the purpose of kubelet. And kubeproxy is a network proxy that runs on each node in your cluster, implementing part of the Kubernetes service concept. So maintains network rules on nodes. This network rules allow network communication to your pods from network sessions inside or outside of your cluster. So this is going to create a cluster environment. Okay, it's like your master and your worker nodes all together. It is going to create a network. Okay, so that your pods can go and talk to the external world, or maybe from this worker node to this worker node internally this cluster, and from externally to communicate, it's going to use this group kube proxy component.
Is it like
So
overlay?
uses the operating system.
Yeah, Praveen,
Yeah.
is it like overlay?
Yes.
Okay.
So the sending the traffic between the cluster and to access from the external, so kube proxy is going to maintain it. Okay. So these are about the components, and the important thing you want to know is pod. So what is pod? So here pod, this pod and containers also will be available inside the master node, sorry, in the worker nodes. So pod is basically a scheduling unit, okay, in the Kubernetes. So just like a VM in VMware. But here, till now, when we were talking about the virtual machine and inside we install container Docker, we are creating containers, only the single container. But here, the pod is directly here. There is no concept of containers, because here it is going to have a concept of pod, and inside a pod, it is going to have a containers. Okay, so in a pod, it is going to have, it's like a wrapper. Okay, pod is like a wrapper, and inside that container will be there. So why they are giving, why we directly can't use as a container, why they're adding another layer called pod, and inside the pod it is having a container? Because so in a pod you can have multiple containers also. Okay, so in a pod you can have multiple containers. So why we need multiple containers? First of all, so here if this is a pod, then you can have multiple containers inside this pod. Okay, so basically in real time, mostly one pod means one container only. We don't create multiple containers inside. For example, if I want to deploy application, we'll deploy it as a pod. But inside a pod, it will have a single container. But sometimes there will be two containers also will be there. Okay. Like for example, we have a concept called a sidecar container, init container. These are some concepts. So along with your application container, there is an other concept called like sidecar container is also needed inside your pod. So what it will do, for example, logs. For getting the logs of this application container, will beside we have another container inside the same pod, which is called sidecar container. This will take all the logs of this your application container, and it will send it to the elk. Okay, you know, right? Elk, Elasticsearch, Logstash, and Kibana. Okay, it will, so to monitor, to get the logs of your applications, we need to configure log aggregation. So elk is there, EFK is there. Okay, EFK means Elasticsearch, Fluentd, and Kibana. Elk, Elasticsearch, Logstash, and Kibana. Its difference is L and F, Logstash or Fluentd. For Kubernetes cluster recommendation is EFK, Elasticsearch, Fluentd, and Kibana. So while implementing this, we can use the sidecar container inside this pod. So it will take all the logs from this container, and this sidecar container will send them to the Fluentd, and that Fluentd will send again it to the Elasticsearch. Okay. So like this, in some scenarios, we may need to have multiple containers in a pod. Mostly application container will be only one. Along with that, either init container or sidecar container will be inside this pod. Okay. So that's the reason here we have a concept of pod. Okay. Let me see whether. So that is the purpose of the pod. It's like a wrapper. Okay. Inside that, it can have multiple containers. And see, obviously, this is an orchestration tool. So for containerization, it is going to use Docker. So with a Docker, there is no use of this Kubernetes. So it will use means Kubernetes will support Docker and Rocket also. Both the containerization tools it will work. Okay, but mostly we are going to use Docker only for container runtime. And okay, this is what pods and containers are going to be run inside the specific worker nodes.
Question.
Yeah.
So Docker is a container that runs inside a pod.
Yes. See, Docker will not run
Hello?
inside the. Can you
Can
able
you
to
hear
hear
me?
me? Yes, I can hear you.
All right. I'm asking that, is it Docker container that runs inside the pod?
Yes, container will run inside the pod.
Okay.
So you mean group of containers is called as a pod, or
See, not group of containers. It's up to us whether we want to run one container or maybe multiple containers. Okay. So one container, one pod. When I'm deploying an application, that application will go and deploy as a single container. Okay. And inside this pod, it will be a single container. Along with this application container, if I'm expecting some other features, like as I said, one of the example is to pull the logs from the container, it needs another container should be available inside that pod. So at that time, we will configure the sidecar container, or else one application you are deploying. So this will be having one container, on top of that, it will be a pod.
Yeah, I remember reading some. Yeah, I remember reading some documentation. As Praveen said, it is a wrapper. That part is fine, but in Kubernetes you can scale up or down. Though scaling up or down is only the pods. So pods can be added. Multiple pods can be added for the application. So each pod may have one container or more than one, as Praveen said. I understand. But the why pods are required means you can scale up like an auto scaling and all. You can add multiple pods.
Okay, so that's why they using this concept, like it's like a wrapper inside that one container will, when I am deploying, let's say an application, so that application, when I deploy, it will create a pod, and it will, inside that it will have one container. Okay, so when you are deploying that, what you are mentioning multiple containers should be inside that or single container. If it's a single container, then it will create only single container. Okay. Along with the application container, if you are expecting like sidecar container or init container, in the configuration, if you define that, then it will have multiple containers. Means one is for application to run and one is another for his sidecar container. If you did not mention these two configuration in the YAML files, then obviously it is going to have only single pod with single container. That's it. If you mention two replicas, okay, then it is going to have two pods. So it is going to have two pods, and here also it will be having one container, and here also it will run one container. Okay. If you mention three, then three pods will run. In each pod, it will have one container. That way it will work. Okay.
Got it, Praveen.
So these are the components of this master and worker nodes. Now, the how we can install. See, basically that is a very difficult part to understand about how we can install this Kubernetes and how we can do practice.
Praveen, question.
Yep.
So where does this pods run containers in Docker environment? Docker containers run on Docker host. Similarly, where does these pods run?
On the worker nodes, here itself, in the worker nodes only, it will get created. The pods will get created.
Virtual. Okay. So nodes run on virtual machines like EC2 and all, right?
Yep. Yeah, that is what we'll discuss now. Like how we can implement this. Here we'll discuss now. We have different ways. Okay. So we have different ways to configure this one. This we need to understand. Okay. So one is Minikube, one is Kubedium, Cops, Kubespray, Kubernetes as a service. So what is Minikube? So Minikube, again, let me go to this documentation part. Concepts. So if you see learning environment and production environment. Learning environment, you have a concept called Minikube and another concept is called Kind. Okay. I think this Kind you can also install on our laptop. Okay. So Minikube learning environment. So Minikube is basically for developers or even for us also, like if we are a DevOps engineer or Kubernetes administrator, whatever you want to achieve before implementing inside the real-time environment, so we can test it on our local environment. So what we can do, we can have this Minikube locally and we can do the practice over our local environment, and then we can do the same inside the real environment. Okay. So instead of directly we should go and implement in the real environment, even though if it is a staging or development environment, still if you don't want to directly implement. And apart from that, learning purpose also, like you can learn yourself how this Kubernetes will work. Okay. It's like a single machine will act like a master and your worker nodes. Even your laptop can also act like a master and worker nodes. But in the Minikube, you are not going to get all the features. Okay. Means whatever the Kubernetes features are there, it is not going to get all the features. So Minikube supports the following Kubernetes features. Apart from this, it contains a lot of other features are there. So it is not going to support those features. Only few features it will support. So you can locally you can configure this Minikube concept. So for example, even developers want to do how their application will run in the Kubernetes cluster. Okay. So instead of they also want to deploy into the real environment, they can have this locally and they can test their application deployment. They can configure YAML files and they can do that. Okay. So that is the purpose of Minikube. And in real environment, if you want to use, then we can use Kubedium deployment tools. Okay, so bootstrapping clusters with Kubedium, Kops, and KubeSpray. So if you see Kubedium, Kubedium is the method you can install the cluster from scratch. Means you created virtual machines. Whether the virtual machines you created from VMware world, means your on-premises data center, or maybe any of the cloud, whether it's an AWS or GCP or Azure, you created virtual machines and manually you download Kubernetes software and prerequisites, everything manually you will do it from scratch. Okay, each and every step. So that concept is Kubedium concept. Okay, so manually we are doing, and if anything issue comes, and we are the responsible to configure it. Okay, to troubleshoot everything. Okay, so you can see installing Kubedium here. So these are the steps. I have separate document in my GitHub so that I can show you. And these are the ports need to be allowed. Okay, for our practice, for example, if you are taking any cloud environment, so we can allow all ports accessible as an allowing in the security group. But in real time, you cannot allow all the ports. You need to allow only specific ports. So these are some important ports should be allowed. Okay, for worker node, these are the ports, and for master node, these are the ports. Okay, so whatever the API call we send, that API call receives the request to this port 6443. Means whenever I'm typing kubectl command and creating or getting the information, I said it will send the request to API. So here this will run on the 6443 port. It will send request to here. Okay. So on the Linux nodes, how we can use it? The complete concepts will be there, and same will be available inside the, like for example, CentOS. So this is a repository, Kubernetes repository, from where we can install the packages. Okay, so we can configure this repo inside the master node, and you can execute command to see. This is the command to install the packages. Kubelet is a package, Kubedium and kubectl. It will install, and after that SLNX you can disable it, and then you can start the service. Okay, so it will act like a Kubernetes cluster. For that you need to create this one virtual machine, and at least you can have minimum one worker node. You can have more than one worker node also. To maximum it will support 5000 worker nodes in a cluster. Okay, so this is the Kubedium concept. As I said, Kubedium concept, you need to manually implement it, and you are the responsible to troubleshoot it. Okay, and coming to the COPS, COPS is bit automated. Previously, COPS was supported only for AWS environment. Okay, it's like, for example, here Kubedium concept. Assume I want to implement it on AWS virtual machines. So what you need to do? You need to um, first of all you need to configure VPC, and you need to configure subnets, and you need to create virtual machines. You need to configure auto scaling for that, so that if any of the virtual machine goes down, then immediately it will create one more virtual machine, right? Auto scaling. So all these concepts you will configure, right, for it, and then you will install Kubedium, and then manually you will install everything. So instead of doing all this, COPS will do all these things. It will do configure auto scaling, virtual machines creation, subnets, VPCs, all the requirement whatever is read, it is going to do. Previously COPS was supporting only for AWS, but now COPS is also supporting for different platforms also. If you go to COPS GitHub,
Question: how does
yep,
EKS and Cube ADM, I mean, what's the difference? AKS and ADM and Cube ADM, what's the difference?
I am not started about talking about that, so we'll talk about this one, Kubernetes as a service. That will clarify your doubt.
Okay.
So here this COPS, so COPS helps you create, destroy, upgrade and maintain production grade highly available Kubernetes clusters from the command line. AWS is currently officially supported with GCP and OpenStack in beta support. So as I said, AWS is fully supported with COPS. Previously, they were not even trying to do this in the GCI and other environments, but they're in the beta version. Okay, with GCP and OpenStack in beta support, and we spend on other platforms. So what it will do if you are using in the AWS, and you can see DigitalOcean or OpenStack environments also, you can do it. Okay, so it will create everything for you, and you can see the official document of COPS here. It will save your time. Okay, and release. So mostly it's not support in the Azure. So in the GCE and DigitalOcean and AWS, but in full-fledged it is going to support in the AWS itself, the COPS concept. Okay, and Qspray is also we can use, and Qspray is like automation way where we can use Ansible playbooks, or it will have the Terraform scripts so that we can implement in our production environment. So this is another way of implementing the Kubernetes cluster, the Kubespray.
Praveen, so using the Kubespray and COPS, can we install Kubernetes on on-premise?
On premises,
Yes.
no. On premises you cannot use COPS. COPS can be only used for AWS. Apart from AWS, it is going to be used in GCE and OpenShift. Okay, and that is also in the trial version. COPS you cannot use in the
Cubes,
traditional
can we
data
use?
center. Kubespray I never tried to implement it on premises. Okay, so here if you see, yep, I think so. vSphere means you can, on the traditional data center we have a vSphere VMware environment. So, and yes, on bare metal also it will work. Can be deployed on AWS, GCE, Azure, OpenStack, vSphere, Packet, bare metal, and or direct bare metal also. Qspray will work. Okay, so high available cluster, composable, choice of network plugin for instance. Okay, so we can use this. Previously this was not available, this was introduced recently. So you can try how to install the Kubernetes cluster with Kubespray also. Okay, so we can implement, it will use some Ansible playbooks and or Terraform scripts also, you can create that. So this is how to create. Okay, so majorly this is deals with the Ansible, so you should have a bit knowledge about the Ansible. And coming to the Kubernetes as a service, So here in the Kubernetes as a service means what? It's a managed service. So here AKS, EKS, and GKE. So these are the three services providing by, this is by Azure, and this is by AWS, and this is by Google. Okay, so means GCP cloud. So the difference between these things and this is, there's a lot of difference. Managed service means what? In the cloud, if you take infrastructure as a service, platform as a service, software as a service, right? So this is like a little bit of platform as a service and software as a service, because when we go to Azure and we are creating AKS cluster, okay, so we are not going to manage it. Everything is responsible by the cloud. So, and it doesn't take much time and much knowledge to create the cluster also. Here, for example, if we take Kubedium, manually we are downloading the software and we are creating this master server, and this worker nodes, we are installing the software inside each and every worker node. But in the AKS or EKS or GKE, we are just creating a service. For example, in AWS, we have a service called RDS database. Here manually we are not installing RDS database, those who know about AWS. Okay, so remaining guys, you could just ignore it. In like generally, if you want to install a database on a physical machine, what you will do, first OS team will install operating system, and then that guys will give it to the database team will connect, and they will install the database manually, and lot of steps will be there. Through VNC setup they will connect and they will install the database, and they'll configure kernel parameters, OS parameters, then database will be ready. But if you take RDS, it doesn't need much knowledge, and we are not installing also. It's an, and even though if an issue comes, we can go and ask the vendor, okay, what is the problem with the service, because it's like a platform as a service. Same way here also, they are giving this service, so you are not going to see this machine. Only you can send API calls. They are going to give a URL. Backend, it's their responsibility to manage high availability for master, because the cluster is, this is main important. These worker nodes, one got deleted, one is created, that is separate. But here we can't see this machine. Only we can send the API calls to this machine with the URL will be there when we create, and we can able to see these are like a virtual machines. Okay, so for any of this environment, we can see it's as like a virtual machines. And the benefit is, if any issue comes with the Kubernetes, we can immediately raise a case with the cloud vendor. So they will come online, and based upon the severity ticket we open, they will troubleshoot the cluster issues. So here in this environment, your responsibility to troubleshoot it, or else you need to contact the Kubernetes community. There is no phone support, so you need to take the community support and you need to troubleshoot it. But here, it's their responsibility. For example, see, for example, I want 3-node cluster. So we are going to create 3 virtual machines, means directly not virtual machines. We have a service called Kubernetes service inside each and every cloud vendor. While we are creating, we will define how many machines we want. We select 3, then 3 will be created, and as I said, we'll send an API call to the master. So for this, they are not charging anything, and cloud vendor will charge only for the virtual machines which got created. Okay, so obviously it will be advantage, right? Because this concept also, we need virtual machines, and same virtual machines we are created here, and vendors are not charging you for the Kubernetes. Actually, till June, even Google Cloud was giving free for the software. But from June onwards, they started charging $0.10 per hour for giving the support for this Kubernetes. Okay, and I think even AWS also charging something, but Azure is not at all charging for Kubernetes software. They will charge only for this virtual machines which are using as a workers. And for masternode, they are not charging anything. Okay, because we can't see that machine where it is running. Backend they might be running on a containers. Okay, we don't know that. We will send only API calls. Means whenever we use kubectl command, okay, so it will go to this API URL, and from there it will do the operations. And we want to create pods, delete the pods, or whatever we want to do, everything will be done here. So that is the advantage of having the cluster. Again, how we can choose which vendor we should go, that again depends upon your organization, means your project where you are working. Because it depends upon, let's say if we take an example, these applications need to connect the Oracle database. Okay, obviously assume database in separate environment, and applications microservices need to be deployed into the cluster. So which cluster you choose? Because Oracle database is outside. Let's say you want to use Oracle database also in the cloud. You don't want anything should be in the on premises. So Oracle database should be running as a platform as a service, and my microservices should go and connect to that cluster, the database. Assume this is a um, database which is a platform as a service inside the cloud. So what are the microservice we are creating here? It should go and connect to some application need to be connected to the database. So which cloud is best for this one? Can anyone tell me? This is an Oracle database. So here, how the customers will decide which cloud will be chosen, not only how they are supporting the Kubernetes cluster, also what kind of applications you are using. If your application is using, let's say I'm saying Microsoft, this one Oracle, or else if it is a Microsoft MS SQL database is it, okay, then it need to be connected to the MS SQL database. Then how? So in this scenario, Azure, let's say Google Cloud. Basically, Kubernetes is the product of Google. So most of the people will think that, okay, let's go with the Google because it's the product of Google. So we'll get very good features. But the problem is Google doesn't support Oracle database and doesn't support properly even Microsoft SQL also. I mean MS SQL. They'll support only MySQL server, and they don't support properly MS SQL, Microsoft database, and did not at all having Oracle database inside the cloud. If you go to the GKE, GCP, you don't see Oracle database over there. So obviously you should run that database out like in the on-premises data center. If the customer doesn't have on-premises data center, then for database, you should go to some other cloud, and then you need to merge the both the clouds. So instead of that, if you go to EKS, so AWS supports Oracle database, so they may choose EKS. And let's say if it is a Microsoft database, then Microsoft database, then you can go with the AKS. So like this, what are the services providing by the cloud vendor, and our requirement, your application team requirement, what are the dependencies of your application, what are the other components it is expecting, and those components are available inside that cloud or not need to be verified by us. And then you need to recommend which cloud is better. For example, you got opportunity to migrate the application from maybe on premises or maybe from cloud to the cluster, Kubernetes cluster. So then how we are going to validate, that depends upon you need to work with the developers architecture, and then you need to take the prerequisites, what it is expecting, what is the dependency of that application, what are the other things it is using, what is the messaging queue it is using, whether it's RabbitMQ or something else it is using. Okay, databases, which databases it is using. Okay, so all this need to be considered, and pricing also you need to be considered. Okay, and then we can recommend, okay, which cluster, which vendor is good for our organization. Based on that, it will be decided. Okay, simply we cannot tell which one is good. EKS is good or AKS is good. Like for example, your application is mixed of Windows components and Linux components. Linux components are running on AKS, so Windows components you can use AKS. Okay, because Azure is very good for Windows components. So in that way, you need to check, okay, which one is managing. So that's how we will use which vendor. So in real time, mostly every customer will use this setup because we are getting service, and also it's very easy to manage. And here, if you are using your own environment, again you need to manage high availability for your master server, because if some, assume it is a Kubedium concept, you install cluster software inside this master. For this server also you are charging, right? So this is getting charged. This is another virtual machine. And second thing is, to maintain high availability, you should maintain 2 or 3 master servers. So you are going to use more machines here, so the price will be high. But if you are using this concept, master servers, they are not charging, because they might be using containers for high availability to run the master. So that's why they might not charging for us. Only they are charging for these worker nodes. Okay, so it's advantage. And lot of other features, like for example, in the Azure we have a concept called virtual machine scale set, like auto scaling concept inside the AWS. So if let's say I'm deploying lot of applications, so this machine is having 16 GB RAM and 32 CPUs, okay, or 32 GB RAM, 16 CPUs. Almost all the 3 machines are full with the existing pods. When we deploy new pods, or maybe existing pods are utilizing it's very busy, then pods need to be scaled up. Okay, we will define like a pods minimum 3, maximum 5. If minimum 3 exceeds, means more load is coming on 3, it should scale up to 5. But when the new pods are trying to getting created, if the virtual machines, this worker nodes doesn't have enough capacity, then it should create these virtual machines immediately. Another virtual machine, another one. So the pod should be created here. And whenever the load is normal, again these pods will get deleted, and these virtual machines also should be get deleted. So this we can achieve with the concept called virtual machine scale set inside the um, Azure. And in EKS, it's a concept of auto scaling we can configure, and a lot of other benefits will be available. Okay, so if you are using Kubernetes as a service. Okay, so tomorrow we'll see either COPS or Kubedium. Do you want me to show Minikube also, or you guys can do Minikube by yourself to install Minikube, all these things? Or else I will show you
Praveen, it would be
Kubedium
great
and
if you show that.
sorry.
I said it would be great if you'll show that, because we don't know anything about this Kubernetes thing.